Hi friends, welcome back. This is Rebecca from AEON Laser. Today I'm going to show you how to adjust beam passes for double tube in our Nova Super machine. Let's get to do it. Before we get started with alignment, let's go through the process in advance. We set up double tubes for Nova Super machine, a high power glass tube, and an RF metal tube. So we got two alignment processes to go. Let me first introduce each one of the mirrors. This is glass tube. The mirror facing the glass tube, I call it mirror A1. This is RF metal tube. The mirror facing the metal tube, I call it mirror B1. These are mirror 2, mirror 3, and mirror 4 on the gantry. And mirror 4 is on the top of laser head. The beam from the glass tube first hits mirror A1. Then it's reflected onto mirror 2, then mirror 3, mirror 4, and finally reflected vertically on the surface of the material. The beam from RF metal tube first hits mirror B1, and the following beam path is the same as glass tube, which passes through mirror 2, mirror 3, and 4, and finally reflects on the surface of the material. Let's get to do mirror alignment for glass tube first. Before we do the operation, let me show you the tools we're going to use this time. To get started, we open up these two side panels of our machine. Open up this panel. This is glass tube, and this is RF metal tube. Now we go for glass tube. There is a bracket here. You can move the tube forward and backward by adjusting these 4 screws. And unscrew these 4 nuts. So you can use this rotary knob to control the height of the tube. Now, what we need to do is to adjust the position of glass tube. Mount an acrylic target on the circular hole, which is directly opposite the glass tube. Take a shot and try to let the beam pass through the exact center of that circular hole. This is the shot we took. It's almost in the center, so it's done. After adjustment, lock every screw right here. Now we come to this side. Unscrew these 4 nuts and remove this whole part with mirror 2. Break the plug here. Take off this whole part with mirror 2. Put an acrylic target on the bracket under mirror 2. Make sure that you push the target against the bracket and take a shot. If you look at this burr, it was over to the left, so we should adjust the knobs to try to get the beam in the center. The way you turn the knobs will control which way the beam turns. As for the left knob, if you turn it clockwise, the beam will go to the right. If you turn it counterclockwise, the beam will go to the left. As for the right knob, turn it clockwise, the beam will go up. Turn it counterclockwise, the beam will go down. So in order to get our beam to the right, I need to turn the left knob clockwise. Before we do that, unlock the knobs behind. Then turn it clockwise. Let's take another shot to check. This time, the burr mark is in the center. Great! To make it easier to observe the motion trail of the beam later, now project the red light on the center point here. You can move the red light by adjusting these 3 screws. Let's do it. Since the whole part with mirror 2 needs to be installed in the following operations, now we align the beam from RF metal tube to be in its burning point. Let's go to the RF tube operation. Use a screwdriver to take out the screws and remove the big cap. First, adjust the position of RF tube. These 2 brackets here. Control the height of RF tube. If you tighten the taut screws and loosen the short ones, the tube will rise, and the opposite situation will occur in reverse. These two brackets here control horizontal position. If you tighten the top screws and loosen the short ones, the tube will move outward. In reverse, the tube will go inward. Change a piece of tape on acrylic target number 1, mounted on the circular hole which is directly opposite the RF tube. And switch to RF tube mode and take a shot. This is the shot we took. It's exactly in the center. Very good. Next, come to this side again. You can see that we are still in the RF tube mode. Now switch to glass tube mode. In order to facilitate the observation, change a piece of acrylic target under mirror tube and take a shot. Due to the previous adjustment, we got the burn mark in the center. The next thing we have to do is try to get the beam from RF tube to the same position. Now switch to RF tube mode and take a shot. This burn mark is a little bit low and over to the left, so we should make adjustments. Let's adjust these two knobs. For the knob located on the right, turning clockwise will raise the beam up. In reverse will lower the beam. And the second knob here located on the left, turning clockwise will move the beam to the right. In reverse will move the beam to the left. So our adjustment should be a clockwise turn of the right knob to move the beam up, and another clockwise turn of the left knob to move the beam to the right. Now the RF tube burn mark is finally in the same position as the one from glass tube. Great. Put this whole thing with mirror tube back. And lock all the screws. Next, take a near and far shot on y-axis. Try to get the burn marks on the center of the targets and have two marks overlap. Switch back to glass tube mode. Then jog the gantry all the way to the back. Mount acrylic target number 3 on mirror 3 bracket. Push it against the back wall. Make sure each side is nice and flush. And put a tape on it. Take a shot. The burn mark is low and to the right. In order to try to get the beam as close to the center of the target as possible, we have to raise it up and move it to the left. Now we make a slight turn of these two knobs. If you remember from the last mirror, the knob on the right is what adjusts the laser right to left. If we turn it clockwise, the beam will go to the right. Turn it counterclockwise, the beam will go to the left. The other knob, turn it clockwise, will lower the beam. In reverse, it will raise the beam up. Again, we start by unlocking this first. Then turn the two knobs counterclockwise. Let's check again. This time the mark is in the center, so good. Jog the gantry to the front side to take a far shot. This is the center point we got from the near shot. To make sure that the beam is shooting parallel right down the baseline, the far shot burn mark needs to be in the same location as this center point. Press the pause button. You can see the far shot burn mark is still a little bit low and over to the right, so we need to turn the knobs in order to get it overlapped with the near shot mark. The adjustment operation this time is the same as the near shot operation. Turn the two knobs counterclockwise. Take another pose. We got one burn mark in the same spot as that near shot mark. And don't forget to lock the knobs behind. And to provide reference for a later operation, now project the red light on the overlapping point. Right now, the beam pass test from mirror 2 to mirror 3 is finished. It's a turn for alignment from mirror 3 to mirror 4. It's exactly the same as the last one. It's still necessary that the burn marks of the near and far shot be in the center of the targets as far as possible and overlap. Jog the gantry to the left. Install the circular acrylic target right on mirror 4, which is in front of the laser head. Push it against the back. Put a tape on it. Press the pause button. The burn mark is a little bit to the left, so we should make adjustments with mirror 3 to get it to the right. Let's make adjustments with these two knobs. The knob on the left adjusts left and right movement of the laser beam. Turn it clockwise, the beam will go to the right. In reverse, the beam will go to the left. The knob on the right adjusts up and down movement of the laser beam. Turn it clockwise will move the beam up. In reverse, it will lower the beam. Now we should turn the left one clockwise. Then check again. This time the mark is almost in the center. Very good. Now we should take a far shot and get the far shot burn mark overlap with this center point. Jog the gantry to the right. Press the pause button. This is the shot we just took. Obviously, it's low and over to the right. So we still need to make adjustments with the knobs to get it overlap with the center point. Let's turn the right knob clockwise to bring the beam up, and turn the left one counterclockwise to move the beam to the left. Then take another shot. Good, this time they coincide at the center point. Again, project the red light on the center point. Alright, the red light is now on the center point. Now that all alignment before mirror 4 is finished, let's go to align the vertical beam path of mirror 4. We need to adjust the vertical direction of the beam path so that the beam can pass through the small hole below. This is the small hole. And finally, get to the surface of the material. Let's remove the nozzle. And put a board on the work table. Press the pause button. It can be observed that the beam mark position is too offset, so adjust these two knobs. Try to make the beam mark be positioned vertically below the laser head. We are going to get the beam down and to the left. For the knob located at the bottom, turn it clockwise will get the beam to the left. In reverse will get the beam to the right. And the second knob here, turn it clockwise will get the beam down. In reverse will raise the beam up. So our adjustment should be a clockwise turn of the bottom knob and another clockwise turn of the second knob. Press the pause button again to check. This time the burn mark is almost in the center. So next we put the nozzle back. As you can see, the red line has already come out of the small hole. The next thing we do is to take a near and far shot on the board. Now press the focus button. Then take a pose. This is the near shot we took. Then move the work table down. Take a pose again. Obviously, this far shot is shooting perfectly in the same spot as the first near shot. If you find out that the far shot doesn't overlap with the near shot, just adjust these two knobs again. Next, project the red light on the overlapping point. By now, all the mirror alignments for glass tube is done. It's time to align mirrors for RF metal tube. Since glass tube and RF tube both need to pass through mirror 2, 3, and 4, and we have already got an ideal beam path by doing mirror alignments for glass tube. Now we only need to align the beam path of the RF tube with beam path of the glass tube. As the near and far burn marks of glass tube on y-axis have coincided, now we can choose any point on y-axis to align two beam passes. Since we have just done the mirror alignment operation under mirror 2, so we will directly choose the middle position of y-axis here. Now we only need to align the beam path of RF2 to the beam path of glass tube on this position. Let's get to do it. Now we are still in a glass tube mode, and draw the gantry to the middle position. Mount acrylic target number 3 on the bracket. Make sure each side is nice and flush. Put a tape on it and take a shot. Okay, we got the beam spot from glass tube on y-axis. We need to get the beam spot from RF tube overlap with this spot. Then switch to RF tube mode. Take a pose again. We found that the beam spot from RF tube is on the lower left of the glass tube. Now we need to move the beam path of RF tube up to the right. Let's make adjustments to mirror B1 to move the beam spot of RF tube onto the spot of glass tube. Then take a pose again. Very good, the two beam passes almost overlap on the middle position of y-axis. Now move mirror 3 to the furthest end of y-axis. Repeat the previous steps to see if the two beam spots coincide as well. Good, they overlap. If you find out the beam spots doesn't overlap, just continue to adjust mirror B1. So far, we have completed the adjustment for beam path of RF tube on y-axis. Next, we only need to align the beam path of RF tube with the one of glass tube on x-axis. Then all the beam path adjustment work is basically completed. As the near and far burn marks of glass tube on x-axis have also coincided, so we can choose any point on x-axis to align the two beam passes. I recommend you to choose a far point. Switch to glass tube mode. Mount the circle acrylic target on mirror 4 bracket. Push it against the back. Put a tape on it. And take a shot. We got the beam spot from glass tube on x-axis. Next, we align the beam path of RF tube to this beam spot at both the near and far points on x-axis. And let's continue to do the work. Jog the gantry to the left. Switch to RF tube mode. Pose at the near point. Okay, the two marks overlap. Let's move mirror 4 to the far point of x-axis. And pose again. We find that the RF tube burn mark is over to the right. So make adjustment to mirror B1 again and move the beam spot of RF tube onto the spot of glass tube. To get the beam moving to the left, let's turn the upper knob counterclockwise. Let's take a pose to check. Two spots coincide perfectly. That's so good. The last step, we have to check whether the light can come out of this hole in the mode of RF tube. Let's put a tape on it to check. And press the pose button. The light comes out. Now all the beam path adjustment work is finally finished. That's everything in today's video. Thank you so much for watching. If you come across any problem, leave us a comment. And don't forget to subscribe us. See you next time.